Darren. And Darren, you're on mute.
Can you hear me now?
Yes.
Sorry about that. All right, thank you, Sally, and the Washington Space Business Roundtable for hosting the important event today, and welcome to each of you online, and thank you for joining us. Since its inception in March of 2019, the Space Development Agency has been focused tirelessly on defining and unifying the national defense space architecture and its layered, proliferated approach. Emerging threats and changing market dynamics have increased the need for resiliency and rapid fielding and deployment of space capabilities. Under Dr. Tournier's leadership, SDA has been able to demonstrate the speed and agility. Both the transport and tracking layers went from draft RFP to on contract in less than 6 months. In addition to rapid acquisition, there's an increased need to focus on interoperability and open architectures and standards. In order to support all domain operation, it's critical that our systems utilize open architecture standards and be interoperable with legacy and future platforms. This requires the development and release of new standards similar to the OISL standard recently released by SDA and OMS UCI standards championed by the Rapid Capabilities Office. From an industry perspective, I can say firsthand that we're committed to the vision, to accelerated acquisition timelines, and to the interoperability in order to provide vital space capabilities to the warfighter. SDA's vision of moving fast, rapid development, and fielding next-generation space capabilities for a warfighter is being realized, and I am thrilled that Dr. Tournier is here today to share with us his latest progress. A little background on Dr. Tournier. He's the director of the Space Development Agency within the Office of the Undersecretary of Defense for Research and Engineering. He previously served as the Assistant Director for Space, responsible for developing the research and engineering roadmap to address future gaps in the DoD and space architecture. Dr. Tournier held leadership roles in industry, most recently as the Director for the Harris Space and Intelligence Research and Development Activity. Prior to industry, Dr. Tournier held positions at the Intelligence Advanced Research Projects Agency, IARPA, and the Office of Director of National Defense, DARPA, and Los Alamos National Lab. Dr. Tournier has a PhD in physics from Stanford University and a bachelor's from Purdue University. He's a recipient of many awards and honors for exceptional public service. Please join me in welcoming Dr. Tournier. Derek, the virtual stage is yours.
Well, thank you very much. Thank you for that introduction, and thank you to WSBR for this opportunity. So, you know, the two pillars that WSBR are really trying to enforce, you know, talking about the commercialization of space and just building that up, as well as educating the Washington community about this opportunity. You know, this is great. I'm really happy to talk about this. So what are we doing at SDA? So the next slide talks about the two main capabilities that we're focused on. So the Space Development Agency is focused on delivering capabilities as rapidly as possible to the warfighter. That's what drives us every day. And the two capabilities that we're focused on are, number one, beyond line of sight targeting for time-sensitive ground and maritime targets. What that means is I want to be able to detect, track, and target mobile missile systems and ships, detect them, actually calculate a fire control solution, and send that down to a weapons platform, all from space. That is capability number one. I want to be able to do that and close that chain within a single-digit seconds. Capability number two is the exact same mission. The only difference is the target. Now the target is advanced missiles that are in flight. I want to be able to detect them, track them, identify them, actually calculate a fire control solution, and send that down to a weapons platform, all from space in single-digit seconds. That's impossible until it's not. See, I couldn't see the video, but the soundtrack was awesome. So thank you for that. But that's the goal of the Space Development Agency. Those are the two capabilities. Everything you hear about when I talk about our plans and how we're doing this is focused on those two capabilities, how we get those capabilities fielded as rapidly as possible. All right, so the next slide, we'll talk about why we needed the Space Development Agency and what role does it actually serve within the Department of Defense. Well, as mentioned, my previous role before joining government was Director of Research and Development, right, at Harris Corporation. And so one of the things that I was tasked with was make sure that I could come up with the technology and the research and development to ensure that we would win our next big programs of record, right? That's what kept the lights on. That's what pushed our business forward. And that's essentially what the business was comprised of. We had well-established customers and we delivered them a product. However, part of that business was also the legacy Kodak folks. And so those folks could tell you very well what could happen with a disruptive technology. So part of my research and development portfolio was to make sure that we could defend against any future disruptive technology, or better yet, create that disruptive technology to gain new market share. So in doing a lot of research to try to figure out how to balance those two priorities, I really fell in love with Clayton Christensen's book, The Innovator's Dilemma. And in that book, it basically makes the point very clear. And that point is you cannot do both in the same organization. It says, look, you will develop resources, processes, and values that are optimized to either answer a given customer that you already have well established and give them a low-risk incremental solution for a product that they will buy, or you will develop resources, processes, and values that are completely different and are focused on a broad range of customers where you will celebrate small wins, and that will allow you to develop a culture around disruption. So since you can't do that in the same organization, Space Development Agency was established outside of the traditional space acquisition organization to be that constructive disruptor within the department. And that's the role of the Space Development Agency, to develop a completely new architecture to be able to develop and deploy our space capabilities. That architecture is based on two pillars. Pillar number one is proliferation. So hundreds and hundreds of satellites. That's pillar number one. Pillar number two is spiral development. And that's important. What that means is we will deliver new capabilities every 2 years. We are not going to slip schedule or increase cost to make sure we can develop exquisite capabilities. We are going to have a minimum viable product that we field every 2 years. If there are capabilities that we need or want that we do not get on that given tranche, is what we call them, then we will just fold that in and deliver that in the next 2 years. And we will continue that spiral development model. So that's what sets this architecture apart. That is what makes it disruptive: proliferation and spiral development. So the next slide, we'll talk about the details of what that architecture looks like. So based on those two pillars, we developed the architecture that we call the National Defense Space Architecture. On the slide here on the right is a functional block diagram. This is what we are building out, and this is what will provide those two capabilities. So in the dark blue box there, the light blue box, sorry, is transport. That is the backbone that ties everything together. Those are hundreds of satellites that are all optically connected with laser comm links that provide a mesh network in space to give you that low latency connectivity. In addition to that, those satellites also provide the low latency tactical data link directly to the warfighter. Right now, that's link 16. We're going to demonstrate this and field it over link 16 because that is the most prolific tactical data link in use today. That's the transport. That's what ties everything together. From the transport layer, all of the other capabilities are reliant. So now let's talk about that box within transport. That says nav. That's for navigation. Essentially, we get navigation for free inside of the transport layer. So if I have hundreds of satellites all connected optically, I form a mesh network that I can calculate precise position and time on those satellites. Now, I'm not GPS. I don't have the power of a GPS satellite, so I'm not going to broadcast that signal out like GPS does. But what I can do is I can embed that PNT, position, navigation, and time message onto the tactical data link so folks can get that as a navigation message on top of the communication channel that they are already receiving. So that's another way to get alternative PNT in the event the GPS is denied. That's the backbone, all right? That's transport and navigation. Now, where the real power comes is when you can start to add sensor data on top of that mesh network. That's what the layers are to the right. The first one, the green, is tracking. That's our OPIR layer. That is the missile tracking layer. That allows you to be able to do the detection, tracking, and fire control for any advanced missiles. Right now, that layer is being built out by SDA and MDA are building out the satellites to be able to do that mission. Next one down is custody. That stands for target custody. That is our ISR layer, intelligence, surveillance, and reconnaissance. So these are constellations of satellites that can be optical, they can be synthetic aperture radar, they could be SIGINT, whatever. SDA is actually not building out these satellites. SDA is working with mission partners, both inside the government and commercial industry partners, to make sure that whatever ISR capabilities they are fielding, we want to be able to take those data and get those to the transport layer as rapidly as possible, where those data can then be fused with other data sets used to calculate a fire control solution that the transport layer can send down to a weapons platform. So that's the custody layer, taking all of those feeds, getting them to the transport layer, and getting it to a weapons platform. The next one down is emerging capabilities. This is in essence saying, okay, we have a spiral development model. That means that we are going to test out capabilities on a given tranche that we may want to proliferate on the next tranche. So that is a new way to test out new sensor capabilities. Originally, this was focused on space situational awareness sensors, but it's the way to test out those capabilities for the next tranche. Now, what ties all this together is that gray box around all of the other functions. That's the battle management. Battle management is the onboard processing that enables all of this autonomous tipping and queuing, autonomous network routing, and the autonomous fire control calculation. That is a federated or cloud computing processing architecture that essentially lives primarily on the transport satellites, but you are utilizing unused processing capabilities on those satellites and distributing it out for distributed processing. Once you get those solutions, then you will send those down via the transport satellites. Now, in the gold in the bottom is the support. That is, of course, we have to launch these satellites. We have to provide ground command and control of these satellites. And then if there is any special user equipment, it will be handled by the support cell in that support box. That is the National Defense Space Architecture. That is what encompasses what we are building in a nutshell in that functional block diagram. Now, on the next slide, we'll talk about kind of the time phasing of when we will deploy these capabilities. At any time at SDA, we will have 3 generations of our tranches. So we will have what is ready to fly currently. That is essentially what we are just getting ready to launch. We will have the tranche that is in execution. For us, that is tranche 0. So these are satellites that are currently under contract and being developed and prepared for launch. And then we'll have a tranche that is in design. So these are the ones that we are just getting ready to solicit to go under contract, and those will be launched and operated after the in execution tranche. So what is ready to fly right now? So this year, we will launch several satellites that are doing tech demonstration missions. Now, SDA is not really a tech demonstration house. So what we do, we team with mission partners. So we team with DARPA, we team with AFRL, we team with others such as MDA to do tech development, and we'll work with them, and then we will transition that into our tranches. So what we're doing in 21 is we're actually flying 2 satellites originally that were set to be launched in January. These satellites were built and delivered to the launch facility 9 months after receipt of funding. That's incredibly fast. Now, unfortunately, they were damaged at the launch facility, so we needed to repair them, and they'll be launched in June. Additionally, on that June launch, we will launch 2 additional satellites to demonstrate cross-links between one another. So they'll have optical cross-links, same as the original satellites, optical cross-links to demonstrate that feasibility with commoditized optical systems. And then we're also working demonstrations to go optical to ground and optical to airborne systems. So those 4 satellites will launch in June. In addition, we will launch an OPIR demonstration satellite. This was in conjunction, SDA and MDA built this together. This is a Northrop Grumman payload that's going to go on the Cygnus ISS resupply mission in July. And the idea there is to just collect data in OPIR for that missile tracking mission to make sure we can essentially vet our algorithms and make sure we understand the clutter environment. So that's all going on in our risk reduction demos. And then we've got some software and some other development work going on to do some ground-based demos. Tranche 0, those satellites are all on fixed price contracts being built for delivery now. We will have 20 transport satellites ready for launch in September of 2022. Those will form a mesh network in space to be able to demonstrate the ability to form that mesh network autonomously and send data down via Link 16 into networked systems. In addition to that, we will also launch 8 wide field of view OPIR satellites that will be able to demonstrate the feasibility of the missile tracking, advanced missile tracking, hypersonic glide tracking mission. So they'll be able to form a network, do detection, send data to transport, and transport will get those to the ground. We will also demonstrate the capability to form that nav message on board, and then we can embed that into different communication signals. Tranche 1 will be ready for launch in September of 2024. At that time, we're looking at the transport satellites only. We have tracking that are in plan, but they're not currently budgeted. But the transport satellites are budgeted for approximately 150 satellites to give you that full global coverage to enable you to do that low latency comm mesh network solution. All right, so the next slide goes through the spiral development model and talks, in essence, these are the bumper stickers of the minimum viable product for each tranche. So tranche 0, just coming up in 76 weeks, just under 76 weeks, we call that our warfighter immersion tranche. So the goal there, the 28 satellites, 20 transport, 8 tracking of the wide field of view systems, they will form the initial kernel of the mesh network and the capability that the warfighters can then use in their exercises and start to develop their CONOPS and TTPs so that they can incorporate that into their war plans. Tranche 1, that's when we essentially have initial warfighting capability. So now we will have something close around 150 satellites to be able to give you this mesh network in space that you can plug and play into with your Link 16 radios and maybe some other tactical data links to enable you to have that connectivity so that it can affect a fight. Tranche 2 will essentially be continuing the same thing in Tranche 1. We'll build it out with more satellites so that now we can have full global persistence around the, 24/7 all around the globe to be able to give you that low latency connectivity. Tranche 3, this is how the spiral development model works. Tranche 3 will then roll in any lessons learned from essentially Tranche 0 and 1. If there was any new technology that was developed or demonstrated on prior tranches, it will be rolled into Tranche 3. And then, of course, the threats will also change along this time as our adversaries develop technology, and Tranche 3 will fold in different capabilities to target those threats. And then Tranche 4 will continue to build, and that's how the spiral development model works. This is revolutionary compared to the traditional requirements process, where you define what the threat is, what the technology is that's currently available, and how you can go after it, and then you design a program that has multiple years of development to be able to deliver that capability. This is a much quicker instantiation to be able to get those capabilities fielded. All right, so then the next slide talks a little bit about how we do this and where we're located and what we're doing. So the majority of our technical team is located in Chantilly, Virginia, and they're essentially where we do a lot of our work. We have a core group in the Pentagon, but then we also have groups that are spread throughout the country. So COVID made a lot of people work remotely. We have always embraced that model and went to where our partners were and where we could find the right talent and bring those people on to contribute to the mission. So I'd like to point out, we have folks down at the Cape to help us with our ground operations. We have folks at LA Air Force Base to make sure we're synced with Space and Missile Center out there and the developments. Folks at Schriever Air Force Base to make sure we're tied in with what's going on in Colorado Springs with MDA and with U.S. Space Command now there, that's currently there, to make sure that we're all tied in and all of that's working smoothly. We have folks in Huntsville. That's actually where the headquarters of our Warfighter Integration Cell resides, and they're making sure that we're tied in with the warfighter and the different combatant commanders across the globe. Grand Forks Air Force Base and at Redstone, that's where we're planning to have our Mission Operations Center for Tranche 1 and beyond. So that's where we actually intend to fly our satellites out of, do all of our satellite and network operations as well as mission operations done out of Grand Forks Air Force Base to make sure that we're tied in to the tactical air community, especially the tactical UAV community that the Air Force has in North Dakota. And then in Redstone, that's because that's where the Army is doing a lot of the development work and the command and control for long-range fires and being able to do beyond line-of-sight targeting. So we want to make sure we're tied in with those groups there. So that's why we're looking to those two locations for our mission operations. All right, so the next slide talks a little bit about what we've accomplished. We're actually pretty proud of the fact that within 9 months of receipt of funding, we were able to deliver those two satellites. Those are the two satellites that are pictured in the photo below. Those satellites were delivered. They are going to do optical crosslink demos. They will be launched in June. They damaged for the January launch, but that's unfortunate, but we'll continue to move forward. We've awarded all of the contracts for the flight hardware for our Tranche 0 to be launched in September of 2022. Those were all awarded on firm fixed price contracts, and so we're pushing forward on those. For ground on those, for Tranche 0, that's being handled by Naval Research Laboratory. And most importantly, the Space Development Agency, because of these successes, we are being praised within the Pentagon as the change agent. So what was coined the constructive disruptor amongst the department, which is a big deal that we're pretty happy that had happened. Now, the next slide just briefly shows, this is the chart I like to say. This shows that we're not messing around. These are all the contracting actions that we have that took place in 2020 to make this a reality. We've been extremely busy pushing forward to make sure that we can get these satellites built and delivered on time. So the next slide is our Tranche 0 team. You can see here for the transport satellites, 20 satellites, 10 each delivered by Lockheed Martin and York Space Systems. So they're delivering the transport satellites to be able to do that mesh network. Ground, as I mentioned, is being done by Naval Research Laboratory. We have a mission systems engineering and integration partner in Perspecta. And that's the only cost plus contract on here. Launch is being done by SpaceX. It was a commercial launch procurement. And then tracking, we have 2 teams on tracking. We have the L3 Harris team that is delivering 4 of the wide field of view satellites. And SpaceX is delivering another 4 wide field of view satellites. Northrop Grumman and L3 Harris are working with MDA, each to deliver a satellite for the HBTSS, which will eventually be part of the tracking constellation. So that is what makes up the Tranche 0 team, if you will. All right, so the next slide talks about, why is this happening now? The hallmark question of why now. Essentially, it's because the commoditization and what's been done in the commercial industry has driven down the prices. So when I first briefed this concept in 2019, folks within the Pentagon said, that's a great idea, but the satellites you're talking about are going to cost between $1 and $200 million. I said, no, I don't think so. I think they'll be, on the order of $15 to $20 million. And what we have now is we have contracts, firm fixed price contracts for our 20 transport satellites, average price of $14.1 million. So that is what enables this. That is what makes this a reality. In addition, Tranche 1, which is not on contract yet, but that solicitation will go out later this year. We had an RFI. We got RFI responses back to say, hey, what do you think the price of this would be if we were going to buy these at this kind of quantity? Those solicitations, the responses came back actually significantly less than the $14.1 million. That just shows commoditization has burned down the price of these satellites that really enables this proliferation. That's how you get resiliency, and that's how you get persistence, by being able to throw up hundreds and hundreds of satellites at this kind of cost point. All right, so the next slide, what's next? What's next? Well, I already talked about we're going to do those demos. Then we're going to launch and operate Tranche 0. And what we've got for the rest of this year, things to watch out for. So Tranche 1, the solicitation will go out this year. We plan on releasing that RFP in August of this year. That's for the transport satellites. As I mentioned, tracking, we're still in the planning stages for, so that's not funded. So don't expect a solicitation for tracking this year. But transport, we will have that solicitation. Right now, we have an RFI on the street asking some very specific questions that will help us inform that RFP, just to make sure we're on the right page. And then we plan on releasing the draft this summer, and then we'll go out with the full RFP in August. All right, so the next slide is just some baby pics that I like to show. So Mandrake 2, those are the 2 satellites that were built and delivered within 9 months. The one on the bottom, that is General Atomics, what we call Link system. So those are the other 2 satellites that are being developed. So those Mandrake and Lynx are going to make up the 4 satellites that are launched in June to do several different optical crosslink satellites, and optical to ground and optical to airborne. We're also investigating utilizing those satellites for that. Purple, that's the SDA-MDA mission that I mentioned. That's the Northrop Grumman OPIR system to be able to take background measurements to make sure that we understand the clutter environment. So these will all be launched this year. All right, so the next slide is kind of a takeaway, just a flyaway slide to show, this is who's doing what times. I already mentioned all of the demos going on in 2021, and then the real meat is in 2022 when we launch the 20 transport satellites and the 8 wide field of view satellites. In 2024, that's when we launched Tranche 1 with approximately 150 of the transport satellites. What we're planning on, but we're still working within the department, is a Tranche 1 for tracking to give us a global OPIR tracking mission, and that would be on the order of 40 satellites. So we're working to try to get that plan in place. All right, so the next slide, what we would actually demonstrate for Tranche 0. We are going to demonstrate that we can do a tracking detection, tracking of a hypersonic glide vehicle, send those data down via transport to the ground, calculate a track solution from those data, send that track back up to the transport satellites, and then have the transport satellites send those down into theater. That's one of the use cases we're going to demonstrate as a capstone demo. In addition to that, we're also working with mission partners to show that we can take data from them, use that to calculate a fire control solution by another mission partner, such as the Navy or someone else, calculate a fire control solution, send that up to transport, and then transport can send that over and send that down via Link 16 directly into theater. Those are the capstones that we will demonstrate to show the utility of how this will work. That will show how the warfighter immersion tranche can be utilized and allow the warfighter to put that into their exercises to develop their CONOPS. All right, so the next slide. How do we actually develop future capabilities? So we are not a tech development house. We expect other people to essentially develop that technology, and then we will proliferate it once it gets mature. But what we want to do is we want to make sure that we communicate to industry and our government mission partners exactly what technology areas we would like to see developed. In addition to that, I want industry to understand that we at SDA are creating a market. We are going to be buying these satellites, on the order of 150 every other year to be able to launch and provide these capabilities. That is a stable market that you can plan on, and you can say, well, I expect to win 20, 30, 40% of that market and plan accordingly. Now, if you develop offerings, or if you work with our mission partners that are more attuned to doing technology development to come up with a product offering, that will allow you a better chance to get a larger portion of that market share. So what are the offerings we would like to see for future tranches? Well, I have that kind of spelled out here, but essentially, transport, the big issues with transport are anything that can do more data feeds down to the ground, more data feeds on the crosslink, so optical crosslinks, electronically steered arrays for going down to the ground, anything along those lines in a small size, weight, and power and cost. Those are the technologies we would like to see developed. On the sensing side, any novel sensors there that can be proliferated, whether that be electro-optical sensors, OPIR sensors, synthetic aperture radar sensors, or we're also looking at sensors that could be hosted that would allow us to do the space-based weather missions, space-based or terrestrial weather measurements, because that's of keen interest to the Department of Defense. We want to be able to do tactical weather forecasting. So those are the kind of sensor technologies that we would like to proliferate. Now, battle management is an area where I think that there's a lot of tech development that needs to happen. So this includes low size, weight, and power, but high bandwidth crypto units for these kind of systems to be able to do that on board. That's a big deal. Multi-level security, so I can do processing anywhere from secret to top secret to unclass, all on board. That's a big deal that takes a lot of technology development. And then any of the algorithms that can actually do the autonomous tipping and queuing or the autonomous network routing, all of that is technology that we would like to see furthered so that we could proliferate that and be able to really get the utility up to make this a feasible type of mission as we fly hundreds and hundreds of these satellites. So that's kind of the tech and the capability roadmap that we would like to see other people develop and then be able to feed in as an offering into our system as we proliferate it. All right, and so that really is Space Development Agency's mission, present and future in a nutshell. So on the next slide, just talks about our mission. Semper Citius is our motto. That means always faster. And our unofficial motto is better is the enemy of good enough. Our goal is to get these capabilities fielded as rapidly as possible, because capabilities in the hands of the warfighter are more important than better capabilities that are sitting on a shelf. So thank you for your time, and open it up to any questions. Darren, I think you muted.
Can you hear me now?
5 by 5.
All right. Yeah, so questions are just pouring in. I've got one here to get us started. We'll wait for the queue to fill up and we'll move to that one. So one of your last charts, Derek, you really talked about kind of tech investment areas in the tech roadmap. If there was one specific space technology you think isn't getting enough investment or attention on that, pretty broad set of capabilities to help you meet your timelines, what would it be and why?
So the one that causes us the most consternation is the small size, weight, and power, high bandwidth crypto. And then if you take that a step further, if you can do multi-level security crypto, that's the one where I think is not getting enough attention, primarily because the technology to do the processing has completely outpaced the thoughts that people in the crypto world would ever think was feasible for on orbit. So you can do a lot of high bandwidth processing crypto in a system that takes a lot of power and is very expensive to run. But now we have these satellites that are essentially supercomputers on a very small and affordable platform. But if I want to be able to do decryption on board, that's kind of a hole that doesn't exist. So that, I would say, if I had to pick one, that would be the one I would pick.
All right, thanks for that response. So let's see, our first question in the queue is from Randy Lieberman. Randy, if you're out there, unmute yourself and go ahead with the question.
Thank you, and thank you for an interesting presentation. Yeah, my thought is that China is really building an alternate universe. They play with their own rules, their own mentality, and it's often contrapositive to the way that we think from a Western rationalist point of view. They had no compunction on January 11th of 2007, as you remember,
right,
in knocking out one of their satellites, causing a whole load of space debris that created a certain amount of havoc. By your setting up these satellite constellations, and I understand why you are, we are, but at the end of the day, if you kind of look out into the future, isn't this a Maginot Line? Isn't it something that if we get into the nitty-gritty of things, these will be taken out pretty quickly? Then what?
So excellent question. Yes, I remember that. That was 800 kilometers, if I recall correctly, is about the altitude that ASAT test was done, and it has debris that still persists to this day. Certainly, these satellites will not be invulnerable to ground-based weapons. I'll talk about ASATs because obviously, in the Department of Defense, we're not building these. We're not building these for just peacetime uses. Obviously, the key we want to build them is to make sure that we can project those two main capabilities for beyond line of sight targeting and advanced missile targeting so that we deter any attack. So, the ultimate goal is that we never will have an attack. But we have to plan for what would happen if there was one. So I'll talk about a few threats and then our response to them. So, you have direct ascent ASAT, which is the missile shot from the ground that hits a satellite. That was the Chinese test in January of 2007. You have directed energy from the ground to a satellite to try to take it out. You can think of lasers or high power microwaves, those kind of things. And then you have cyber and other attacks. So of those, our defense against essentially the first two is in the case of proliferation itself. So when you made a statement there that they would be able to take out these satellites pretty quickly, I'll push back on and say, well, the pretty quickly depends obviously on what time scale you're talking about. I don't want to go into details about how fast I think these could be taken out in an all-out war, but I would say pretty quickly is probably, depending on what that means, is probably an overstatement. So what I would hope is that in the proliferation, the whole model behind proliferation is that if you really do get in a shooting contest where people are damaging and taking out these satellites, then that will give you enough time to have resilient capability so that you can have other effects. You can respond with other effects to say, okay, we know you're essentially attacking our sovereign capabilities. That's an act of war. We have other escalatory effects that we can take out now at this point before we actually lose all our capabilities. So if you had all of this capability on a single satellite, by the time they took out, they showed their intent of wanting to have a war, wanting to attack your capability, you have lost all your capabilities. So that's the big thing that I think that the proliferation buys you over these large, exquisite, high-value, juicy targets, as General Hayden calls them. Now, as far as the directed energy one goes, so we're at 1,000 kilometers is notionally where these satellites will be flown. That's high enough to where I contend they're fairly well protected. Cyber and supply chain are two of the threats that I'm concerned about. So the reason I'm concerned about those threats, because the main reason that the main way we're defending these satellites is via proliferation. We'll have hundreds and hundreds of these satellites. Cyber and supply chain problems are common mode failures. So it doesn't matter if I have one satellite or if I have 1,000 satellites, those may have the ability to take them all out. So those are the threats that I'm most focused on, because those are the ones that I think can have the biggest devastating effect. Whereas the other threats, I actually think proliferation gives us significant advantages. In fact, I would go so far as to say that Tranche 1 and beyond, it will cost more to shoot down a satellite than the satellite costs to actually put up there and operate. So we've completely changed the equation on that.
Thank you.
All right, next question's from Peter Garriston. Peter, if you're out there, go ahead with your question.
Yes, thank you. So the original SDA briefing also considered cislunar SDA and cislunar response vehicles. Is that part of what SDA is still considering? And does SDA have ambitions to get into orbital warfare and the space control console?
Thanks for the question, Peter. So if the functional block diagram that I pointed out, we actually changed what was called deterrence. We changed that to emerging capabilities. That deterrence is still embedded in emerging capabilities, but primarily what we were looking at in deterrence was situational awareness in that cislunar environment. That's really what we were focused on. We weren't as focused on any kind of offensive capability. We were just focused on being able to characterize any threats in that cislunar environment. And the reason we took that off and went to emerging capabilities is because that's one thing we're considering, number one. Number two, we actually feel that AFRL has been making a lot of good progress in that, and we're collaborating with them to make sure that whatever they field can plug into our transport layer so we can get those data down. But we think that there's other entities within the department that are now focused on that cislunar environment, and we're letting them run with it.
All right, our next question in queue is from Courtney Stad. Courtney, unmute, go ahead.
Great, thank you, Derek. I have to tell you, for those of us who attended one of your first industry days, the progress you and the team have made is unbelievable, just fantastic. So real tribute. Since we're inside the Beltway, allow me an inside the Beltway question having to do with budget. Understand you're constrained in terms of getting into detail until the president's budget's request, but from your vantage point, are you, shall we say, optimistic that the FY22 will give you the resources that you and your team need in order to continue on the path that you've laid out? And there were references to SDA being absorbed by the Space Force in the 22 time period. Is that still on track? Thank you, Derek. I'll go on mute. Thank you.
Certainly. Well, anybody that knows me knows that I'm an optimist to a fault. So I'm of course optimistic about the budget, but more so than that, I have some data that can substantiate that. So what was in President's budget request in FY21 certainly gave us had in there the plans to do everything I've discussed today, and nothing has changed within the department that I can tell as far as priorities and needs and this kind of overarching plan. So I have no reason to believe that there's going to be any significant reshuffling to say, no, this is not the road we want to go on now. And so I think the successes that we have had have been, that is what we've been hanging our hat on to say, this can be done. I believe that, the funding we received in FY21 was certainly the funding to say, okay, we'll give you enough rope to see if you can hang yourself. And I think we've done exceptionally well to hit all of our milestones. We brief OMB and Congress quarterly to say, hey, these are the milestones we said we were going to do. This is our plan, and this is what we've been doing to make sure that we're completely transparent about if we have problems or if things are going well, and what changes we've made here or there, or what trades we've done. Because of that, I think we've got people have gained confidence that this model, this spiral development model, actually works. So I'm very optimistic about 22. All right, and then I'm sorry, what was the second part of the question?
Oh, in terms of the Space Force.
Oh, yes, yes. How could I forget? So that is actually in law and part of our plan that starting in FY 2023, so October of 2022, Space Development Agency will transition out of R&E, out of OSD, and into the Space Force. Now, what the law also did was it put some very clear guidance to make sure that the acquisition authorities and autonomy that we have now that is allowing us to continue to move rapidly will transition along with us, which is great. And it goes to that again. We're giving you enough rope to see if you hang yourself or if you actually deliver. And I think that's the intent of the law, is to say we want to give you these authorities to make sure you can continue to execute. As long as you can continue to execute, we'll continue to let you be. Now, the reason we're going underneath the Space Force, it's actually there's a lot of positives there. So if you notice, I talked a lot about SDA is going to deliver these capabilities. Now, when I say deliver, that means deliver to whom? The combatant commanders are our actual customers. So we will provide these capabilities, the beyond line of sight targeting and the advanced missile targeting, we will provide those directly to the combatant commanders. Now, in theory, we really couldn't do that under R&E, right? As part of a defense agency, we're not part of a service that is out there to organize, train, and equip. That's really the service mission. So that's why moving us inside of the Space Force actually gives us the capability to say, okay, now you can operate these satellites, you can field these capabilities, and you can do that mission. And so that's why we're looking at the mission operations centers at Grand Forks and Redstone to say this is what we would actually use to be able to get these capabilities to the warfighter. So that's why we will move in October of 2022, and that's kind of the reasoning behind it.
All right. I'm not sure who asked the next question because it came through as J59437, but I'll ask the question on their behalf, Derek.
Darren, it's Manuel Juarez from Northrop Grumman.
Manuel, go ahead. J59437. Let's ask your second question, Manuel.
Sure. Yeah. No, that was I'm not sure why the number is, but I just had a quick question about number of awards for Tranche 1, and also maybe if you'd shed some light on some of the standards development and interface technologies that were mentioned in the 2021 budget. Over.
Certainly. So that's an excellent question. So on the number of awards, I'm really interested in industry feedback when we see our acquisition strategy when we put out our draft RFP. Right now, I'll say that what we'd always been kind of promulgating out there is probably 3 awards for those 150 satellites, but we're not wed to 3. 3 is not a magic number. I would have picked pi, but it's really hard to award 0.14159. So what we decided to do was we're going to probably put out there and solicit proposals where people can bid a plane at a time, a complete plane of satellites. We're planning on six planes. And so, you know, you could say, okay, well then, if we're going to have 3 awards, we would probably award 2 sets of 3. But what we're thinking about, you know, when you see the draft RFP come out later this summer, you know, this could all change because this is internal debates. But our thoughts are now is that we would go out there and have people essentially price in increments of a plane on what that bid would be, and then it would be up to us to determine the best value to the government on how many awards we wanted to make. You know, obviously the awards could be in that anywhere from 1 to 6 performers if we bought it a plane at a time. So now the standards work. That's a critical piece. So just to make clear why that's so critical to the audience. So the only way this works, the only way this open architecture future works where I can have people bid and win a certain fraction of the market share is if we do this in a way that has open standards and an open architecture. Now, what we can do is we can define, this is the optical standard, optical communication standard. That's what we did for Tranche 0. And that's what we're going to do for Tranche 1. But that can only take you so far. You know, we'll define the optical standard. We'll also define the networking standard. But then we also want to have a government test facility. That's where we have NRL on board for Tranche 0 to own and operate this test stand, so where people can take their individual crosslinks and their individual networking solutions and plug it into a government test bed. That will validate that, yes, in fact, you have met the open architecture standard and that you can plug and play, and you will be then given authority to go ahead and build the satellites for Tranche 0, Tranche 1, whatever tranche we're working on at the time. So for Tranche 0, you know, that line is snapped. We're moving forward with the performers on that. For Tranche 1, the optical standard for Tranche 1 is set to be released any time now. We've been working. We have an optical intersatellite link working group that has been working on that standard. What we don't want to do is we don't want to define a standard that's out of the blue. So we're working with industry to say, you know, what are you building now? What can be built? We're trying to base this standard off of the standard telecom fiber communication standard so that everything can be made in a commoditized manner. But we expect that standard to come out shortly. And then we would want people on Tranche 1 to bid against that standard. The only thing I can say about it at this point is the Tranche 1 standard will be different than the Tranche 0 standard by quite a bit. And that's primarily because Tranche 0 was just to demonstrate the capability as rapidly as possible. Tranche 1, we want to be more robust. We wanted to make sure that it can be interoperable with some of the future tranches. And we also want to capitalize on the commercial investments.
All right, I think the next question in the queue is from Lou. Lou, if you're on mute, and ask your question.
Great, thank you. Derek, can you talk to the balance between the need for security and trust for this system, these systems that will be used for national security missions with the desire to leverage commercial and in some cases potentially foreign investments?
Certainly. So that's you know, that is it is a fine line that we need to work. We definitely want the commercial and the commoditization. And as I mentioned, supply chain was one of my main concerns. So that's not only just the robustness of the supply chain to ensure that I can get the parts, but also to make sure that I can validate the provenance of the parts once I get them. So there are concerns with using foreign vendors for certain parts of the system. So, you know, for example, flight computers. Flight computers are one that I would say, you know, I would prefer domestic vendors pretty strongly. Some of the optical crosslinks and the networking aspects, that will, you know, that's very close to telecommunications, different aspects. And a lot of that, you know, is being, we have enforced, we have different statutes that say which parts of that can be procured internationally and which parts of that have to be domestic. So we have to work within those. But certainly I would say that we want commercial components. We look at foreign vendors and we do risk assessments on those, and supply chain, measuring the provenance and understanding the provenance of supply chain is a big concern. And so we'll weigh that heavily when we do any selections.
All right, Derek, I think we've got time for just one more question. And so that question is from Jeffrey Trauerbaum. Jeffrey, go ahead.
Well, thanks very much, Derek, for doing this. It's good to see you again. You're understandably focused, obviously, on the space and ground segments for the Tranche 1, which is certainly, again, understandable. Can you offer any initial thoughts about the launch segment in those tranches, both your architectural and acquisition approach for those? So thanks very much.
Certainly. So, you know, for Tranche 0, we did commercial procurement and we just went out for a fixed price bid on that. For Tranche 1, when we did our budget planning, we assumed kind of the same type of model. Now we are working with SMC on an SSL to see if that could actually meet the needs we have for Tranche 1 within our budget constraints. It's unclear if that's feasible, but certainly, you know, the way we're set up uniquely in the launch market. So 1,000 kilometers polar orbit is notionally what we're looking at. Hundreds of these satellites. You can solve that problem a lot of different ways. So we've kind of planned on a launch per plane, that kind of thing with a larger launch vehicle. But as we build out, and even for Tranche 1, it still remains to be seen. There's a couple different debates going on within the agency and within the agency and the Space Force on how to handle that. But as it moves forward, I don't think that's the right way to continue to populate these constellations. The reason being is when I get to Tranche 2 and beyond, I will want to intersperse those new capabilities with my existing capabilities, because these satellites will all last about 5 years. So that's 2.5 tranches. So I don't want to populate a plane at a time. I may want to intersperse them. And so that means that I'm going to be looking at launch capacities that are on the order of a ton to a polar orbit at 1,000 kilometers. So I don't want to launch an entire plane. So that sets us up into a different class of launch vehicle, and one that frankly there's not a lot of launch vehicles in that class right now. And so that's kind of what I see as the future way that we will sustain these orbits. How we actually get that in Tranche 1, whether we go with 6 commercial procurements or whether we actually work within SSL, that's still being debated.
All right. Well, Derek, I think that wraps up our time for Q&A. And, you know, on behalf of everybody on the line, really appreciate you taking the time and the transparent and candid conversation and the depth of the charts and the details. So I'm going to throw it back over to Sally to close it out for us. Just one closing comment from my side. There were a couple of questions in the queue about the availability of your briefing charts to those who were in participation. It's my understanding they'll be made available to those who participated in a PDF format today, unless you disagree with that. Otherwise, I think that's the intent of the organization to provide those out to the attendees.
Sounds good to me.
All right, Sally, over to you.
Great. Thank you so very much, Derek. That was a wonderful discussion. And thank you, Darren, for moderating. That was great. And yes, we will be providing a video of the session today that will include, obviously, Dr. Tournier's slides, as well as the video that we unfortunately were not able to show. So I apologize to Northrop Grumman for that. I did want to announce 2 upcoming events that we have for WSBR. In just 2 weeks, we will have the Honorable House Space Subcommittee Chair Don Beyer on April 28th at noon. And following next month, we will have the Acting NASA Administrator Steve Jerzik on Wednesday, May 26th. And we're hoping that'll be after the FY 2022 PBR is released. So that should be a very interesting discussion. So today we had an absolute record turnout, and I really appreciate every one of you who joined. And please spread the word that we have more exciting events coming up. And again, thank you so very much to Dr. Tournear for a great discussion. Thanks, everybody. Bye.